What I want to do in this video is really make some clarifications and go a little bit more in detail about the different layers of the Earth. So let me draw a cross section of the Earth over here, and I'll try to do it. I won't be able to do it perfectly to scale, but I'll try to do a little bit better job at giving you a little bit of a sense of how thick these layers are. So let's say that this is the crust up here. And I'm going to make the continental crust a little bit thicker. So let's say that that is continental crust, and this is continental crust. And then in between, let me put some oceanic crust, which is going to be thinner. So this right here is, actually, let me do it in a different color. Let me do the oceanic crust in blue. But this isn't water. This is rock. I'll do it in purple. That's even better. I don't want it to be that thick. So let me draw the oceanic crust is thinner than the continental crust, which I'm trying to depict right over here. So this right over here is oceanic crust. And up here is continental crust. Continental crust. And the thickness, or how deep you can go and still be in crust, it depends on where you are. And we know that near hot spots, the oceanic crust can actually thin out a good bit. But roughly, when we talk about the crust, we're talking about something that's 30 to 60 kilometers deep. So 30 to 60 kilometers deep. So if you are on a continent, which I'm assuming you are, and you dig for 20 kilometers, you will still be in the crust. 30 kilometers, probably still in the crust. If you dig for 70 kilometers or 100 kilometers, you will probably reach the mantle. And remember, what we're describing here when we talk about the crust, the mantle, and the core, we're talking about the chemical makeup. Let me make this clear. We're talking about the chemical makeup. The chemical makeup. The crust is fundamentally different than the mantle based on the molecules that it is made up of, based on its composition. So let's talk about the mantle now. So the mantle layer like this, and once again, this is not to scale because the crust, we're talking about 30 to 60 kilometers. The mantle, we're talking about on the order of about 2,900 or 3,000 kilometers thick. So this right here is the entire mantle. So that's the mantle. And this is 2,900 to 3,000 kilometers thick. So this isn't even 1/30th of that. So I would have to draw it even narrower than the way I've drawn it over here. And the mantle itself can be subdivided into the upper mantle and the lower mantle. So let me draw this division. Let me draw this division right over here. The upper mantle, and there's different ways to define the boundary, but you could. The upper mantle is roughly about 700 kilometers down. So these are huge distances. I mean, this is going straight down. So this is the upper mantle. Let me write it on the actual mantle here. This is the upper mantle, and this over here is the lower mantle. And just to be clear on things, so the crust is solid. Now, when you go into the upper mantle, the upper part of the upper mantle, and we'll talk about that a little bit more, is cool enough to be solid. So there is a solid portion. There is a solid portion of the upper mantle. So all of this up here is solid because it's cool enough. It hasn't reached the melting point of those rocks just yet. And we learned in previous videos that the combination of the solid part of the upper mantle and the crust combined, we call that the lithosphere. And when we talk about the lithosphere, we're not talking about the mechanical makeup. We're not talking about what's solid and what's not solid. So this is the lithosphere. This is the lithosphere. You go a little bit deeper, right below the lithosphere. Now the temperatures are high enough for, and I use the word liquid, but that's not exactly right. You can kind of think of it as kind of a deformable solid, or a plastic solid, or a magma. And that's the asthenosphere. So this area right over here, this area right over here, the liquid part. Actually, I shouldn't use the word liquid. Kind of the deformable. It deforms over long periods of time. But it is more fluid than what we normally associate with rock. Magma would be a good way to think about it. That's what we call the asthenosphere. It is fluid, just not as fluid as water. It is more viscous than something like water. So this is the asthenosphere. Asthenosphere. atmosphere. Now, the upper mantle is it's hot enough for the rock to melt and be fluid, and but the pressure is low enough for it to still be able to kind of move past itself, to have to be somewhat fluid. But then once you get even deeper into the lower mantle, you have higher pressure. And so it's still fluid, but it's less fluid. It's kind of thicker, I guess is the best way to think about it in the lower mantle. It's thicker. So this whole area over here, you could kind of think of it as melted rock. It's fluid, but the upper part of the melted rock is more fluid. It's able to move easier because there's less pressure. And the pressure is just from all of the rock that's above it. Remember, gravity is pulling down on everything. Gravity, every molecule here wants to go downward because of gravity. So it's applying pressure downward. So the deeper you go, the more pressure you get. Now, when we get even deeper than that, we get to the core, and the core is divided between the outer core and the inner core. So the outer core, outer core, outer core, and then of course you have the inner core. The inner core. And just so we have a sense for distances, the width or the thickness of the outer core is approximately 2,300 kilometers. So these are huge distances when you think about thickness. You could go down another 2,300 kilometers and you're in or once you go through the mantle, you can go 2,300 kilometers through the outer core, and then you're in the inner core, and that essentially takes you to the rest. That's essentially the center of the Earth. And the inner core, and maybe I should draw it, maybe I should draw the boundaries a little bit more to scale. Let me do it this way. It should actually look a little bit more like this, because the outer core is thicker than the inner core. So the outer core is, as I said, so let me rewrite it. Outer core is on the order, it's about 2,300 kilometers thick. And then you have your inner core. I shouldn't do it in blue, I should do it in a hot color. So the inner core right over here is just kind of takes us to the center of the Earth, and that's a little over 1,000 kilometers thick. So this is the inner core. Inner core, the number I have is about 1,200 kilometers thick. And both the entire core, both the outer core and the inner core, is mainly nickel and iron. And think about when the Earth was forming. What happens is when this whole Earth was super hot and it was kind of in a fluid state, the heavier elements were allowed to sink down when everything was fluid. The things that are in between or the things that were lighter would go up, and then the gases, things that would naturally be in a gaseous state, would kind of bubble up through that fluid, kind of the way actually, carbon bubbles up in a soda. It would eventually bubble out of the fluid, and it would actually form the atmosphere. So that's why when you look at the composition of the Earth, you have the heaviest elements in the center, and then the lightest elements are forming the atmosphere. And the outer core and the inner core, they are made up predominantly of nickel and iron. Nickel and iron. And their makeup is actually very similar. So this division, chemically, they have a very similar composition. What's different about them is at the outer core, you have temperatures high enough that nickel and iron can melt, but the pressures are low enough that they can still be in a fluid state. So this is our liquid outer core. And this has a pretty low viscosity, especially even relative to the mantle. So that's why people kind of consider this in kind of a more traditional liquid state. But as you get deeper and deeper and deeper, the pressure becomes so huge as you get to the inner core. Remember, all of the weight of all of the rock above you, of these thousands of miles of rock above you, is all pushing down on the rock below it. So the inner core, even though the temperature is really, really, really hot, the pressure is so big that the molecules can't flow past each other. They can't be liquid. They're kind of jammed packed. And so the inner core, because of the high pressure, despite the high temperature, is solid. It's solid. So the difference here is actually a mechanical one between the outer core and the inner core. They're made up of the same things, roughly the same chemical makeup. It's just slightly or lower pressure on the outside, so you can actually be in a fluid state. So hopefully that clarifies and gives you a little bit of depth on the makeup of the Earth.